Okay, today we're going to finish off Investigation 2, and we're going to talk about the different layers of the Earth's atmosphere. So as we start to look at the different layers of Earth's atmosphere, we had a worksheet that went along with this. And the worksheet started off with what is the atmosphere. The atmosphere is the layer of air surrounding Earth. So we start to look at some of the characteristics of the atmosphere. We can describe how the air changes as we travel through the atmosphere. As we go up higher, the air starts to get thinner or more spread out, and there is less and less air in the same amount of space. Some of the other things that we look at as we start to talk about the different gases in the Earth's atmosphere and how those gases change as we go through the atmosphere. The variable gases, carbon dioxide, water vapor, and methane, are found only in the troposphere. Those variable gases don't extend very high up into the atmosphere. With that troposphere, that's the layer where weather is going to take place, so it's important that we have that water vapor there. Looking at the composition of the permanent gases, things like nitrogen and oxygen are going to remain the same, close to that 78 and 21%, almost all the way through the different layers of the Earth's atmosphere, all the way up to the mesosphere, and then the thermosphere is where it really changes. And when we get to that thermosphere, the amount of nitrogen is going to go way down, and the amount of helium especially is going to go way up and increase very high. With the next question, describe how the temperature changes as we travel through the atmosphere. The temperature is going to usually decrease as we go through the different layers of the atmosphere, and that's true until we reach the thermosphere. The funny thing with the thermosphere is because it's the first layer that the sun's light and sun's energy reaches, it actually is very, very energetic, and it has a very, very high temperature reading. It can reach up to 1500 degrees Celsius. The problem is the particles are very, very spread out. So even though it's a very, very high temperature reading, you would still freeze in the thermosphere. It's still extremely cold, but the particles move around very fast and have a very high energy. That's why they get a high temperature reading. One of the other things that we would look at is what layer of the atmosphere do you think is greatest of interest to meteorologists? And that would be the troposphere, because that's where the weather takes place. That's where we're going to have our water vapor, our clouds forming, precipitation. And that's the layer of the atmosphere that we live in. So that's the area that is of the most interest to meteorologists. And the final question is what gases are found in the atmosphere and what gases are found only in the troposphere. So the gases in the atmosphere include nitrogen and oxygen, some hydrogen, helium, argon, carbon dioxide, methane, and water vapor. Now with those variable gases that are only found in the troposphere, we're going to focus more on carbon dioxide, methane, water vapor, and they're only going to be found closer to the surface, along with the nitrogen and oxygen. And it's important that we get those variable gases close to the surface. As we look at the different layers of the Earth's atmosphere, with the troposphere down the bottom, that's going to be the layer that living things live in, or all creatures on Earth live in, and weather's going to take place there. So it's actually one of the thinnest layers, but the majority of the atmosphere is found in that. The mass that makes up the atmosphere, about 80% of the mass that makes up this layer is going to be found right here. So gravity pulls down on a lot of the air molecules, and that's why we have a very, very high air pressure, and the atmosphere is very, very dense in this troposphere as well. As we move up, we get into the stratosphere. With the stratosphere, one of the big things is the ozone layer. You can see here the ozone layer is one of the big things that we find there. Another thing that we find in the stratosphere is the jet stream. It's the fast-flowing winds generally moving from west to east. And they move right at the kind of boundary between the stratosphere and the troposphere. It kind of acts as a conveyor belt or a river and that's what pushes a lot of air masses and weather fronts around uh, on Earth. Next, we have the mesosphere. With the mesosphere, this is the area where we get shooting stars coming from. As they come from outer space, when they reach this layer of the atmosphere, they start to receive a lot of friction from the air molecules in this layer, and they start to actually burn up. So things like meteorites actually burning up in the atmosphere, and that's causing this layer of the mesosphere. So that's an important layer protecting the Earth. When we get above that layer, we start to get into the thermosphere. With the thermosphere, again, we talked about this layer a little bit before. With this layer, we're looking at the first actual layer of the Earth's atmosphere. It's a very, very thin layer in terms of the amount of air molecules in that. They're very, very spread out. They are very energetic and they do move around a lot. Some of the other things found in this layer, we have the ionosphere. With the ionosphere, particles that come out of the sun, especially when the sun is having a solar storm, will interact with this ionosphere and the thermosphere, and it will cause the atmospheric molecules in this level of the atmosphere to kind of glow, and we call that the aurora borealis, or northern lights. There's also the aurora australis, or southern lights, for the southern hemisphere. So that's one of the big important things for the thermosphere. As we move up, we start to get into outer space, and we have this transition period from the edge of Earth's atmosphere into outer space, and we call that the exosphere. The exosphere has very, very few air molecules, and they kind of just float by. Some of them stay with the Earth, some of them float off into space. The thickness of Earth's atmosphere can change, and the boundary between outer space and Earth's atmosphere changes a lot of times due to seasons. In the summer, the atmosphere will be a little thicker, and in the winter, it will be thinner. Also, over the equator, the atmosphere is going to be a little thicker as well, and over the poles, the atmosphere is going to be a little thinner. So it's a little tough to say exactly where Earth's atmosphere ends and where outer space begins. A lot of that's done with temperature as well. So if you have any questions, feel free to stop by in class and ask.